The lesson topic for this video is dividing rational expressions. And dividing rational expressions is actually just like multiplying rational expressions with one small change at the very beginning of the problem. You might recall that when you learn to divide fractions, if, for example, we had 2 over 25 divided by 6 over 15, we would do something called multiply by the reciprocal. So what we did is we kept this first fraction the same, so 2 over 25, and we would change the division sign to a multiplication sign, and then we would take the reciprocal of the second fraction. So instead of 6/15, we would put 15 over 6. Sometimes some teachers would call it keep it, change it, flip it. Okay, so that's what we would do here. And at this point, again, it's just like multiplying rational expressions like we learned in a previous lesson. We can simplify these fractions. For example, the 2 and the 6 are both divisible by 2, so I can say 2 divided by 2 is 1, and 6 divided by 2 is 3. And similarly, we can divide 15 by 5 and get 3, and divide 25 by 5 and get 5. And then there's even yet more simplifying we can do in this problem, and that is because we can divide 3 by 3 and get 1, and divide 3 by 3 and get 1. And at the final conclusion of this problem here, we would have 1 times 1 in the numerator, and we would have 5 times 1 in the denominator, and so therefore this problem simplifies to 1 over 5. So we're going to use that same process that we learned long ago, keep it, change it, flip it, when we divide rational expressions. So the first step, we will change it to multiply by the reciprocal, and at that point we have the same steps as we did with multiplying. First, we factor everything that can be factored, whether it's a GCF, a equals 1, magic number. I should have added here difference of squares. People are missing that a little bit. Make sure you pay attention to that. And then we look for ways to make 1, which is another way of talking about canceling out. And then we multiply the numerators, which is straight across the top, and multiply the denominators across the bottom. So let's try a couple of examples. Okay, so here we have a division of rational expressions. So one fraction divided by the other fraction. And the process I would use for this, again, we start by changing it to multiplication. All right, so I'm going to first change this to multiplication. And now I'm going to remember to keep this fraction the way it is, but we need to flip this fraction to get the reciprocal. Okay, now when we do that, what I suggest is simply taking the expression in the numerator and writing it below here. So 2x squared minus 11x plus 5. You can get rid of that. And then move the 1 from the denominator, 2x squared minus 5x plus 2 from the denominator, move it up to the numerator. So now we have changed it to keep it, change it to multiplication, and flip it. And so we moved the two expressions. At this point, it is simply the same as multiplying. So we first factor everything we can possibly factor. So the numerator of the first fraction, we can't factor anything out there. The denominator of this fraction, we can factor out a GCF. It is 9x, and what we're left with in the parentheses is x minus 2. The numerator of the next fraction is an a equals something other than 1 expression, trinomial. So we do want to use the magic number steps. Since 2 times 2 is 4, I'm going to write 4x squared over here and think about the factors of 4x squared. So 1 times 4 or 2 times 2. Notice, in order to get a negative 5x in the middle, what we're going to need to do is make both of these negative right here, and that is our factor pair because they add up to negative 5. So I'm going to separate out my 2x squared and my plus 2, and I'm going to change this middle term here to minus 1x minus 4x. All right, I'm going to then put a vertical line down the center and factor out the GCF on each side. Here I can factor out an x, and I'm left with 2x minus 1. On the right-hand side, remember to factor out the negative, and in this case, a 2. And right here, when you factor out that negative 2 out of the 2, we are left with minus 1. And our parentheses match, and that's great, so we're going to write that down right here. If I can squeeze it in on my screen, 2x minus 1 is our matching parentheses, and we're left with x minus 2 remaining here and here. So we factored the numerator of our second fraction, and now we need to do the similar thing in the denominator. So this time our magic number is 10x squared. And we can say 1x times 10x. And notice that is the correct factor pair because it adds up to 11, but we do need to make both of them negative to add up to negative 11 that we see here. So we're going to separate out 2x squared and the plus 5 and put minus 1x minus 10x in between. Put our vertical line down. Factor out an x, we're left with 2x minus 1. On the right hand side, factor out a negative 5, and we're left with 2x minus 1. Our parentheses match, which is great, so 2x minus 1, and what's left is x minus 5. All right. At this point, there is a lot of stuff all over the place, and one thing you might want to keep in mind is that every one of these steps you've changed until you've gotten to your actual factors at the bottom here, and we've changed all these and manipulated them until we get to our factors up here. So we're looking at the x minus 5. Again, we're not using this any further. We have 9x times x minus 2, a couple factors up here and a couple factors down here. Okay, so what can we now make a 1 or cancel out? We see an x minus 5 here and an x minus 5 here. We see an x minus 2 here and an x minus 2 here. And we even see a 2x minus 1 here and here. When all of this is said and done, our final answer for this division problem that we started with is 1 over 9x. Remember, when I was talking about canceling out, that does mean that it makes 1, remember. So this x minus 5 and this x minus 5, when I canceled them out, it means we're dividing them, which is a 1 over 1. So there is always a 1 remaining in either the numerator or the denominator, even if everything else cancels out on that side. Okay, so we're going to do just one more example. Notice we've got a fraction on the left-hand side divided by an expression on the right-hand side that is not written as a fraction. I would highly recommend that the first thing you do is turn this into a fraction by putting it over 1. Now, you've definitely got to pay attention to whether a problem that you're completing is multiplication or division, because if you forget to flip the second fraction, it will be, of course, wrong, and that will give us the wrong answer and the wrong work, and that is not okay. So we're going to change this division to multiplication, and when we do so, we need to take the reciprocal of our second fraction. Again, be careful. Leave this as it is. We need the reciprocal of this. So I'm going to cross this out, and I'm going to move my 1 up to the top. I'm going to cross my 1 out on the bottom and change the denominator to x squared minus x minus 20 on the bottom. And you might want to move those before you cross them out just to make sure that you're writing the correct signs, like the subtraction signs here. Be careful with all of that. All right, so now we're going to do some factoring. This trinomial right here has a leading coefficient or an a value of 1. That is always handy because it means that we can factor it into 2 sets of parentheses right away. We can have an x in the front of each. And the number 15 is what we're working with here. 15 is 1 times 15, or 3 times 5. It's going to be 3 times 5, but we need, again, both of them to be negative in order to get a negative 8x. So x minus 3, x minus 5. In the denominator, we're going to factor out an x. And again, I'm no longer needing this expression or this one. The 1 in the numerator of the next fraction is fine as it is, and we've got again an a value of 1 here, which makes this a pretty quick factoring problem. Negative 20 is our c term. 20 is 1 times 20, but one of them has to be negative, or 2 times 10, or 4 times 5. And again, one of them has to be negative. So negative 4 plus 5 adds up to 1, but remember we need negative 1, so change the 4 to positive and the 5 to negative. So x plus 4, x minus 5, and we no longer need this expression. Now we make 1 wherever we can. The x minus 5 and the x minus 5, we divide them, we get 1. And at this point, there is nothing left to factor or to cancel out or make a 1. Be careful with this. This is where some people will want to cancel out or make 1 with the x minus 4 or x plus 4s. You cannot cancel these because they're both in the denominator. So what does that mean? What does that mean? That means our final answer is x minus 3 over x times x plus 4 times x plus 4. And by the way, if you'd like to write this denominator here as x times x plus 4 squared, you definitely could do that because we have x plus 4 times x plus 4. So we could write that as x plus 4 squared if you want. But this would be a fine answer as well. Last reminder, you cannot cancel out these x's, for example, because this x is stuck with a minus 3. It's a binomial factor.